Okay, so good evening from over here. My name is Ikichuka Chom. Yeah, I'm the program manager for Codecamp, right? And I'm also going to be your trainer for the Android development track. So you're going to see two sides of me, right? The side as a program manager, right? And then the side as your trainer, right? So whichever one actually hits you, just take it that way, right? Okay, so that's just a brief introduction about me, right? I have with me God first Onoha. He's actually the mentor for the Android track, the beginner track. Okay. He interestingly was part of Code Camp in the previous cohorts as a learner, and he came back to actually be a mentor, right? So he's a very, very nice young man. And even though he's shy, he's a serial volunteer, as he always says. So if you're not able to reach out to me, when you have challenges, in fact, when you have challenges, right, he should be the first person you reach out to, right? If he's not available, then you can actually reach out to me. Okay, so whatever challenge you're having with whatever task that's given, or a class, or you're trying to download something, whatever, right? Or if you need an extra explanation, right, that we were not able to attend to during class, right? He's actually there for you on the channel. God first is his name. Okay, so let's get right to it, right? So yeah, introduction to Android development, right? I think someone asked what we're going to be using. Of course, so Kotlin, right? Before now, um, Java was actually being used, right? Java programming language was used, but in recent times now, what there's been a switch to Kotlin, and there are a lot of reasons why, right? But considering that you guys are actually beginners, and some of you don't even have certain programming level background, if I start to explain the reasons why, it may sound so strange to you, right? So, but this is what happened. Some weeks from now, we'll come back to it, right? So that when I explain it, will make sense because you've actually started seeing these things, right? But I'll just run through a few of them. Okay, so what we'll cover today, right? Um, Hopefully, if time permits, we'll just look at the introduction to Android development and then Kotlin fundamentals, right? Okay, so that's basically what we'll cover today, time permits. So, for an introduction, right? Android development basically is the process of creating applications for the Android operating systems. For all of you that have, most of you that have Android phones, not iPhones, right? So Android is actually an operating system, right? So Android development, you're basically creating applications that will run on the Android operating system, of course, and it's a widely used operating system developed by Google. For I think there's someone who said she was learning Flutter, right? Okay, so Flutter basically is cross-platform, meaning you're creating applications that run on both Android and iOS, right? But we are actually focused on native app development. Native means you're focused on a particular operating system. So you're either building for Android or you're building for iOS, but not both. Hopefully, in the coming cohorts, we will bring in Flutter, right? But I am actually one who I'm a stickler for native app development, right? I do Flutter, but native is actually interesting. Okay, so that's just a basic introduction to Android development, right? So, like I said, if at any point you have questions, you can actually just use the the chats. I can see some persons that already that have actually self-learned, and that's fine. No safety and like that's actually cool. Okay, so let's move on, right? I'm going to try to make this as easy as possible. So, some of the key components that you need to know on the Android development. Now, some of these things I'll just scale through them, right? You get to meet them when we actually get deeper, right? But just to mention them, so you just kind of know that these are components of the Android development, right? The first one there, Android Studio. Android Studio is just what we call an IDE, right, for Android app development. IDE means integrated development environment. So that's basically where you just write your code. That's just how you should see it, right? That's where you actually write and build your application. So it actually provides tools, editors, what we call emulators, right? Emulators is just a virtual phone. You have a virtual device where you can test your application, right? And it just it just gives you tools that you need to build your applications easier, more efficiently, and faster, right? I don't know how many of you know about Notepad, right? Of course, if you're learning front end, in fact, generally speaking, you can actually write your program in a Notepad, right? But the thing about IDEs is this, IDE is actually one of the things. Okay, for example, in an IDE, you have features like syntax, highlighting, so probably and indentation also. They can auto indent for you, right? But imagine if you're actually using writing your code on a notepad, you just indentation is going to be difficult. Not really difficult per se, yeah, but it will just be it will be really, really tasking. So when I'm saying indentation, it's just what you know as paragraph. Just click tab, right? That's basically indentation. So because your code needs to be well properly formatted. But IDs helps you do that. IDs color your code so you know, okay, this particular color represents this represents that and stuff. IDs helps you to also point out errors, potential errors or actual errors in your code, right? Maybe you made a wrong spelling, maybe you're calling a wrong function or variable or any of these things. IDs can help you spot that. But if you're just writing it in a notepad, you probably will not, it will be difficult to even debug, right? And when I talk about debug, I'm just basically saying it's difficult to find the problem, in your code and actually what fix that. So that's basically what Android Studio actually does. So it's an IDE, integrated development environment. So another thing I want to help let you guys know, right? During classes, try to take notes, right? My slides are not usually wordy, like you won't see much words inside. The explanation is just in the head, right? I won't if I don't do wordy slides, so you have to actually take notes. But of course, the video is going to be available on YouTube for you to go back to, right? Okay, another component, yeah, Kotlin. So you have actually Java or Kotlin, right? But for the purpose of this training, right, we're focused more on Kotlin, right? Now, Android apps are actually written in either Java or Kotlin, right? But Kotlin is actually the modern and recommended language for Android development, right? Because it offers a lot of things, syntax, null safety, and it's actually interoperable with Java, right? I think I'll talk about that much later. Okay, so that's just on a high surface, right? Surface level. And then of course activities, right? So an activity basically we'll delve into this, right? It's just a single screen with a user interface, right? So when you open your application, whatever you're seeing, that's actually an activity or a fragment. We'll talk about all these things, but we'll get into that, right? But each screen that the user interacts with, right, is represented by an activity. Okay. um Layouts and views, right? Layouts basically just define the structure of the user interface, right? How this user interface is structured, how are your buttons, your text, your images, how are they aligned, right? So the views itself represents the individual UI components. When I say UI, I'm talking about user interface. So when you open your Facebook, right, the home screen of your Facebook, you have a text, you have your image somewhere, a rounded image, you have texts, and or you have buttons, right? Those are individual what components, right? Your text, your buttons, image, those are individual what components. So they are called views, right? So the layout defines the structure of these views. How are these views arranged together? Okay, how are these views arranged together? um I would advise that you don't distract yourself with unnecessary questions on the chat, right? So you can focus on what is being taught, right? Okay, and then so some other components, right? We have the intent. So intent basically, of course, like I said, some of these things I'll just give you on a high level. We'll dive into it. Intents are basically just used to enable communication between different components of your application. Now a typical example of an intent is when you're on a particular application and you click share, you want to share probably a link, right? It gets to now pop up other applications where you can share this link to, right? That is what's intent. So it enables or facilitates communication between different um, components of your application or between two different apps, right? That's what intents were. So they enable activities to start other activities, to pass data, and a lot of that, right? Now, for fragments, fragments are just they are just reusable user interface components, UI components rather, right? So they kind of just help to build a more flexible and dynamic user interface. So we'll get into that, right? And I'll explain why they're really, really very important. Uh, but just like I said, just on a high level, right? Just want to mention these things. So when you hear them again, you know that you've heard them somewhere. Okay. Another component is the Android manifest. The Android manifest just contains it's a file, right? It contains essential information about your application, right? Like your application's name, the permissions that are required, because when you use most applications, right, you have to give permission for them to use your location, right? For some most applications, right? So that's actually what those permissions are actually stated on the Android manifest, right? And a lot of other things. Now, your resource files, of course, Android uses what we call XML, extensible markup language. We'll talk about, we don't really need to dive into it per se, but when we get there, I'll explain in depth. But basically these are just, it uses XML based resource files to define your layouts, your strings. We'll talk about what strings are, right? Colors, images, and any other assets, right? That, makes it easy to manage, configurations, translations, when you, of course, some of you, when you use an application, right, when you switch to what's it called, landscape mode, right, the it has to actually rearrange the layouts, the views, right, to be able to what you can actually see it very well. If you've used applications where you can switch from English to another language, right, that's possible because of resource files, right? Because it has these resource files, whether it's a string, and with that, it can actually what manage, the way it is being rendered. Well, like I said, all these things will get into that. Adapters, well, okay, basically adapters are just used to connect what we call data sources, right? So one of the things I like to tell people is when you get into a field where you're not really very sure, maybe it's a new field, one of the things I'll help you is if you can just understand the literal meaning of the word first. It can, oftentimes than none, it can help you to, get a contextual meaning, like a meaning with respect to that particular field, right? So when we talk of adapters, so look at the word adapt, right? What does it mean to adapt? It means you're actually now in, let's say you are a Nigerian, and then you actually have to go to the UK. The weather conditions are difficult, but you also have to survive. So what do? You find a way to what? Adapt, to make sure that you're able to survive, live, exist, whatever, with the present conditions. So you have new information, you have new changes coming to you, but you need to be able to take those changes and what make use of them in such a way that you are still, functional, right? So that's just what you should. So adapters are used to connect data sources, maybe where you have, like, for example, your contacts on your phone, right? The source of those, where you stored it, whenever you create a contact, it's stored somewhere, right? So you have, for some of you who stored your contacts on Google, when you switch to a new phone, you're able to still import those things, right? So adapters help you to connect from the data source, right, which could be a list, right, to the views. So when you import your contacts, you now see it as a list. Now, your contacts, when we say connect it to the views could actually be a list view, right? Now, inside of that list view, you now have what we call an item. We'll talk about all these things, but a contact can have an image, a text like first name, last name, and then maybe one icon somewhere that you can use to edit it and stuff like that, right? So that's just what adapters really kind of do. Okay. Next one, networking, right? Okay, so for networking, uh, so actually, of course, your applications often need to interact with servers, right? I don't know, some of you may or may not know about servers, right? Using what's called HTTP. So basically to fetch data, exchange data. So a typical example is this: when you want to upload your profile, right? You upload your image, rather, you're actually sending that image somewhere, right? And of course, whenever you open that your app again, you also need to see that image. So that image is being fetched back to you, right? So that's the whole concept of networking, right? So there are a lot of networking stuff that we're going to make use of. And then of course we have persistence. So now your apps may actually store data locally, right? We'll talk about some databases, right? Um, for offline use, right? You know, you're able to, so from the word persist means that something is able to stay for a long time, right? So you actually have this whole persistent feature on our application, so you can store data that will exist. So let's say I can actually just, how many of you have seen probably a remember me function, probably in a sign up or something, remember me, right? So what are you trying to say? Hey, I've logged in. So for some reason, I want you to save the fact that I've logged in somewhere so that I don't have to always log in. So as far as you don't log out, that information persists because it is stored somewhere, right? That's just, a light example, right? And then of course debugging and testing, right? Debugging and testing. So of course Android Studio is a tool, right? So it also provides us with tools to help us to debug, like find out what an issue is in our code, and to also test it, right? And to also test it. So that's basically just a few of the components of the Android development that we're going to be looking into for now, right? So let's switch to Kotlin. Now, the essence of Kotlin is actually a programming language, right? Now, but let me take a step back. So for some of us, right, you know what the computer is. Now, computers don't understand English language, right? It is important. It's important for you to be able to communicate to a computer to tell it what to do. But to be able to tell it what to do, you need to speak a language that it understands, right? So look at when we say it's a programming language. So let's look at this programming. What's programming? Let me interact a bit. Let me see. People, let's just do a bit of interaction. So what is programming? Who can actually just understand? Give me, like, just say something. Just raise your hand. What's programming? Okay, Abasif, okay, go ahead.
So programming is simply just, giving an instruction to the computer, like carry out this task. Simply just writing codes or programs for the computer to carry the particular task.
Okay, so he said writing codes, programs for the computers. Okay, so let me ask someone else. What is a program? Because he said writing codes. What is that code? What is a program? Prosper.
Um, Good day, everyone. Good
Yeah.
evening. I feel a programming language, according to my knowledge, is like a language you tell the computer to, like, it's the only language a computer understands. I feel a computer understands binary operations. So those binary operations are then translated into lines of codes which the computer still understands. You understand? Like, in my own understanding, I just feel that's what it is, that those binary operations, since we cannot understand and carry zeros and ones in our head all through, it was like in a way translated into, like, those lines of codes. So we just have to attach what we really want the computer to execute, and with that line of code, and it executes it. You understand? I don't know if I'm right, but that's just what I feel.
Okay, let me hear from Evelyn. Thank you very much, Prosper.
Okay, so I think a program is a set of functions or codes that work together to make an application or perform a particular function. Like, I mean, like do something or make things work, if that makes any sense. Sorry.
Okay, okay. Adalinda. I hope I got that name, Adalinda.
Okay. Programming can be my own understanding. I see programming as series of code that can be an input on output of the computer. It's simply a computer language which comprises of code, symbols, and um, some other things that only computer understand.
Okay, okay. Okay, let me hear from China. So I think that's the only hand raised.
Um, programming programming is like the act of writing a program. You understand? Why a program is a set of logically arranged instructions that are executable, in order to provide a desired result.
Okay, so you all are right. Okay, so a program basically is just a set of instructions, right? I like to bring things down to more understandable way, right? So let's look at this. If I actually, like I said, it's just a set of instructions, right? So the instructions could be instructions to actually prepare noodles, right? So if I'm able to give you a step-by-step process on how to create noodles, I've actually given you a program. That's as simple as that is, right? Because sometimes we see these words and we feel that they're just so big, it's just so big. No, 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 no. They're actually not as big as you think, right? So but you all are right. So now you guys have said it. So it's a set of instructions, right? Okay, you give it to a computer. So because it's an instruction, it means you're telling the computer what to do. So you need to use a language that the computer will understand, right? Just like you all are able to understand me because I'm speaking a language that you understand. Probably if I switch to my native dialect, some of you may not understand me anymore, right? So of course, and computers, like you guys have rightly said, computers understand binary, which is just ones and what zeros. Okay, so that's why we'll talk. We'll get to the point where I'll talk about compile and some of all these things, right? So when you actually probably type English or something, an English language or whatever, your computer doesn't see. Let me use this. Let me use this as an example. So when you type 8 to a computer, your computer doesn't see 8. It sees the binary equivalent of what 8, right? So it means that there's a process that converts that your high level language to a low level language, because that's called machine code, but that's not really why we're here, right? We're not here to really start going into computer science terms, but we'll probably just touch it in between, right? So now Kotlin is actually the language, it's the programming language we're going to be using for what building mobile applications, right? All through this cohort, right? So it's a modern statically typed programming language that was developed by JetBrains, right? So what do we mean when we say it is statically typed? Okay, so a statically typed language is actually a language where variable types are explicitly declared at compile time. Now, I've said something very huge for some of you, so let me calm down, right? I just mentioned something called variable. We'll get there actually, but let me just hit it so I can explain when we say that Kotlin is statically typed. Now, a variable basically is just a container. So think of where you're living, right? You have a container that stores water, that stores milk and stuff like that, right? That's just hold that as what a variable is, just a what container that stores what data, right? So but in your house or wherever you are, each container stores a type of, like, what it stores. There's a type of whatever that it stores, right? So there's a container that what it stores, let me use the word liquid to be a bit generic, right? Because what you used to put water, you can also use it to put juice and something like that. You just raise it. So let's just use liquid. So you have containers that can store liquids. You have a liquid, rather, yeah, and you have containers that probably can store what? Solid, right? So that means this container stores a particular type of what, whatever. So when we say calling is statically typed, we're saying that the variable types, that means the type of container, right, is explicitly declared at compile time. I'll explain what compile time means. So it means that you tell me what kind of container or what kind of data that will be stored in this container. So is this a container for liquids or is this a container for solids? You will tell me before you even think of running this code, before you think of executing. So before you think of using, let me even bring it down. Before you think of using this container to put water inside, you need to tell me ahead of time that this container is to store what? Water. That is what explicit what declaration. That's what I mean by explicitly declare at compile time, right? And then, of course, the type of variable is known and checked at this compile time rather than the runtime. So what's this compile time that I'm talking about, right? So compile time basically just you have compile time, you have runtime. These are terms used in software development, right? They basically just talk about the different phases of a program's life cycle. So we know what program is now, a set of instruction, right? A set of instruction, which is a program, has a life cycle, meaning that there's a place it starts to where it actually what ends, right? So now, so we talked about software, the whole software development scope, right? We use what we call compile time and what runtime. Like I said, they refer to the different phases, right, of a program's what life cycle. Now, one is during the process of turning that's your code, you've written, which is called a source code, into an executable what code, right? And that is actually the compile time, right? And then the other one talks about the actual execution of the program, right? So let me dive in a bit, right? So compile time basically is the phase of your program's development when the source code, which is the code you've actually written, right, is transformed into a machine readable instruction or code. So like I said, when you write 8, the computer doesn't see 8, it sees the binary equivalent. So there is a conversion, there's a transformation that takes place that converts it from the source code, which is the 8 you've written, into the binary equivalent. What's the binary equivalent of 8? Somebody should actually put it on the chat. What's the binary equivalent of 8? So we know that 2 is 1 and we have 0, we have 1, we have 1 and 0. 3 is 1, 1, 4 is 1, 0, 1. So equivalent of 8. Someone should put that on the chat. Let's see. So the phase at which the source code is transformed into a code that is readable by the computer, right? That phase is what we call the compile time, right? That phase is what we call the compile time. Now, okay, 1000. Okay, good. So 8 is 1000. So it won't say 1000 actually. I can just say 1000, right? So there's a process, there's a timeline, there's a period where 8 is converted to 1000, which the computer gets that 1000 and then performs whatever operation that is needed with that figure, right? So that's actually that phase, right, is the compile time. So a few things actually happen during this compile time. So like I said, you probably have to take notes, but you go back, sure, it's fine. You can go back to the video. So a few things actually happen during this compile time. One is what we call syntax checking. We'll talk about syntax, we're talking about rules, right? A set of rules that guides, a particular language or something. So syntax, right? So the compiler will check the syntax and the structure of your code, right? Because it needs to be sure that it conforms to that particular language's rule, because every language has its syntax, We'll talk about that. Every languages have its what syntax, has its rules. So it checks your syntax to be sure that, okay, you want to run this code. Okay, this code you wrote it in Kotlin, or you wrote it in Python, you wrote it in Java. So in that compile time, it checks to be sure that you're obeying every rule that applies to that what language, right? So if there's any error, the compiler will actually report it, right? So it also checks the type. The second thing is type checking, right? What type of data, right? Or what type of variable your expressions, what type are you actually making use of? So it checks for what it does, type checking, right? And a few other things it does is code optimization and generation. So I don't want to go, into all that, right? But that's just the compile time. We'll look in depth much more later. Now, another thing is so the runtime is the phase of your program's execution after it has successfully compiled. That means it has converted from your source code to your machine code, right? And is what running. So it has successfully compiled it and it's what running. So during this runtime, you have, your program's execution. So the compile code is now executed by the computer's virtual machine or your CPU, depending on the language and the platform you're actually making use of. So it has switched from 8 to 1000, right? And then it is what running. So whatever instruction you have given giving 1000 to do, right? It's actually what running with that. So that's runtime. Another thing that happens during runtime is memory allocation, because it's something you need to understand about in computer, right? Memory allocation. We'll talk about that actually. Memory is actually allocated for variables, right? Objects, data structures as your program runs. We'll talk about some of these things. So don't worry, don't be scared, right? So that's basically just a few things. There are other things that happens at runtime, right? Dynamic behavior, error handling, of course, if there are unexpected issues that comes up with your code, right? So that's basically just that. So all these things, right? That's why we say Kotlin is statically what type, right? It's statically typed because the variable types are explicitly declared at compile time. What kind of container is this? Tell me before I start using it. That's basically what it's saying, right? In trying to bring that down. Okay, so it's a statically typed. Other statically typed languages, right? I think you have Java. Java is actually statically typed. We have C++, we have Swift, we have C Sharp, right? Those are also statically typed languages, but just for you to know, right? So of course, second thing is that it's designed to be fully interoperable with what Java. So you can actually, of course, when we start making use of Android Studio, you see that it actually Java and Kotlin, they actually they work hand in hand. You can work two of them. You can build an application where you have your Java, you still run Java code and you still run Kotlin, right? But of course, we're just going to be sticking to making sure we write just Kotlin codes, right? And of course, it aims to improve upon Java by offering a more concise, expressive, and usable Okay, please confirm you can hear me. Hello, can anybody hear
I hear
me?
you now.
Okay, sorry, I think network actually kicked me out. Where did you lose me? Where did you lose me? Where did you lose me?
The section where you talked about writing basically we'll be writing Kotlin code, not focusing on Java.
Yeah. Yeah, okay. Well, that's basically just that. Okay, so as far as Kotlin is concerned, right? So we're going to be learning, we're going to be looking at variables and data types, right? Going to be looking at functions, control flow, classes and objects, inheritance, and interfaces. Now, I like to do, there are two ways we can go about this, and I've come to notice that sometimes it's dependent on, the time of the training and stuff like that. So, I can decide to teach you the language first before we get into the application proper, or I could decide to teach you the language and teach you the application. No. So basically, you learn, the first one is you learn the language first. The second one, you're learning the language and you're building the app. So which one would you prefer? Let me see on the chat. The first one, choice one. You can just say one or two. One is you learn the language Kotlin first. Two is you learn Kotlin and at the same time build applications. So on the chat, let's vote one or two. Let's see. One or two. One, two, two, one, three ones, three twos. Okay. So we have three ones and three twos. Who else is voting? Three ones and three twos. So who is winning? Okay. Four ones and three twos. Okay. The ones are winning. The ones are winning. Any other person? Oh, five ones. Okay. Say one wins. Okay. Five ones and four twos. Okay. Is that all? Is that everybody? Is that everybody? 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, that's fine. So that means the one win. So they want us to learn the language first, and then we'll get to learning how to build applications. Okay, I'm fine either way, right? So we'll focus on learning the language first. Okay, so let's actually get into it. Let's get into it. Okay, so for the purpose of this class, right? There are two ways you could actually do this, right? First of all, okay, let me just stop sharing. You could download IntelliJ, right? You could download IntelliJ. IntelliJ helps you to, they're the ones who have Android Studio actually, and some other platforms. You can run a lot of things if it's using IntelliJ. So with that, you can actually run your Kotlin codes, right? So if your laptop can carry it, right? Because Android Studio is a bit heavy. So if your laptop is something that can carry that, then that's fine. But if it cannot, for running of our codes, right, we're going to use you can actually run it online, right, using Kotlin Playground, right? Yeah, Kotlin Playground can actually help you do that. So let me just show you that quickly. Okay, so yeah, you should see it. Yeah, so just go to play.kotlinlang.org, right? So you can actually run your codes online, right? That's if you cannot download IntelliJ. Like I said, all depends on um, you know, um how strong your laptop is, right? Someone says, what type of laptop can carry it? Well, if you have a laptop that has at least an 8 gig RAM, at least, I wouldn't recommend 4 gig, right? I would not. I would recommend 8 gig, right? If you have an 8 gig RAM or maybe a 500 HDD, even if it's 400, right? I think that's actually fine. But of course, you need to also make sure that there are other things on your laptop that, less things that is actually, kind of taking space, right? Android Studio is heavy. So having Android Studio and then having IntelliJ. Of course, you can actually use Android Studio to run some of these commands and codes, but since we're going to be focusing a lot on just Kotlin first, right? I wouldn't want us to use Android Studio for that. It's too heavy for having to use, to do that. So so okay, so somebody said Okay, I think I need to talk to this admin. Can you unmute? Is it Amen or I don't know how is it
Yes,
pronounced?
my name is Amin. Amin.
Amin. Where are you from?
Where am I from?
Yes.
You mean Nigeria or
Yeah, country-wise first. Let's start with
I'm from
country-wise.
I'm from Nigeria,
State-wise. Don't worry, nobody's coming to
Ogun,
look for you.
Ogun State.
Ogun. Okay. So I needed to so that's fine. So he's saying you should buy 500 SSD. I mean, calm down. Do you know how much that is? Okay.
It's just like 25K. I bought mine then 25.
No, it's not. It's not 25K.
No, I mean the upstairs of SSD, the NVMe and SATA. I'm talking about SATA.
Okay. No, of course I wouldn't really go for the other one, but SSD is not 25K.
Old PCs
And
can
it's a 16 gig RAM of this thing, DDR about 20 something thousand. Okay, that's by the way. So if you have a 4 gig RAM, yes, Android Studio runs slowly, actually. Right, it runs slowly, right? Well, one of the things I would advise is don't let that deter you. When I started also, I was using a ProBook, right? 4 gig RAM also ProBook, and trust me, it was slow, right? It was slow, but you'll get to the point where the laptop will not be an issue, but it should not stop your learning, right? It should not stop your learning. So Android Studio is actually heavy. So I'll just prefer you just run your codes on play.kotlin. I think there are other platforms. I'll just get that right across. But this is basically what I'm just going to be using for the purpose of this course, right? AMD processor, well, it's AMD processors, well, they're not really very, very fast though. Intel is actually, I prefer Intel, right? Maybe Core i5, right? But let's not really stay a lot on this, right? Let's not stay a lot on this. Okay, so let's get into Kotlin, right? So we're going to start with variables and data types, right? We're going to start with variables and data types. So what is a variable, right? A variable basically, let's just so start with variable. Please confirm you can still see my screen. Let me zoom in a bit so you guys can see this.
Yes, I can.
Okay, so if at any point you
Yes.
can't see or you can't hear me, please somebody should just call my attention to it. Thank you very much. Okay, so yeah, variables. A variable basically, right, is like, okay, let me just give us a or I say a tech definition somehow, computer definition per se, but it's actually a named, please mute your mic. It's actually a named storage location in a computer's memory that holds a value, right? I don't know if I should type that out. No, I shouldn't. There's no need. So it's a named what storage location in a computer's memory that holds a value. So key things to take note of there. Number one, name storage location. So you must give it a name. A variable must have a name. Okay. So it is a location in a computer's what memory. So it exists somewhere in memory, right? And then of course it holds a value. So it is a named storage location in a computer's memory that holds a what value. So that's just looking at it from you want to look at a computer definition and stuff like that. But basically, it's used to store and manipulate data within a program, right? It's used to store and manipulate data within a program, right? So in Kotlin, right, um, there are variables are there's what we call let me just type this out, right? So variables are declared. There's what we call, let me just say, variable declaration. So remember what I said about um variable just being a container, right? So first of all, since from our definition, right, we said it's used to store something, right? It's a named storage in computers, what mean a computer what memory. So now being a container, right? When we say variable declaration, it basically means that we want to what? Declare a variable. Declaring a variable means you want to create that what that named storage in memory, but you have not stored anything there, but you just want to create it. So think of it as you just going to the market and you've bought a container, right, that you want to use to store something. You've bought the container, you have brought it to the house, but you haven't put in anything yet. You haven't decided, what you want to. Probably you've actually decided, okay, fine, you store water in it, but you have not put water in it yet. That's basically variable what? Declaration, right? And how do we do that? First of all, remember we said that a variable must have a name. So there are two ways to declare or probably initialize. We'll talk about variable initialization. There are two ways to do it in Kotlin. We use two keywords, right? We use keywords called var and var and what? Val. Now, var, which is the var, it's actually a mutable variable. When you create a variable with the keyword var, it means that that variable is mutable. Mutable means that the value can actually what? Be changed after you have put. So it means that that container you actually bought and you said, okay, I want to put water. You can decide to change it and say, I don't want to put water again. I want to put pepper, right? That means that variable, that container is what? Mutable. You can change the what? Value. The value can be changed even after you had said that you want to, store only water. You can change your mind, right? That's the var. But the val, right? The val is what? Immutable. Means that when you actually create this variable, when you buy this container and say you want to store water, you cannot put in any other thing again, right? You cannot even see, you can't even put in more water. That's the val. It's immutable, right? You cannot actually what? Change it once you've bought that container. You've said it's water and you put water inside. You cannot put more water inside. You cannot even remove the water except you want to throw away the container. So you cannot update it. You cannot modify the contents of that what? Container. It is once and for all. So that is the val, right? So we use these two keywords, var or val, to create a variable in Kotlin, right? And how do we do that? So let's start with the val, right? I can just say val. So you can see, this is the interesting thing about IDEs, right? The colors and everything helps you to just, differentiate few stuff, right? Okay, so I could say val, so meaning that I want to create an immutable what? Variable, right? So the next thing is to give the variable a name. So I could call it student, right? Okay. And then talking about variable declaration, which actually I wanted to explain, right? Let me bring it down here. Assuming I want to declare a variable, remember when I talked about variable declaration, right? You just get a container and you say you want to put water, but you haven't put the water yet. So I want to create this variable and say, okay, I want this variable to this type of variable to be a let's say, okay, let me change this to age. I want this variable to actually store only numbers, right? I want to only store numbers in this what? Variable. So numbers, and of course, not just any numbers, integers, right? So I will use a colon and then I'll I'll just do int, right? So int here is short for integers. We'll get into data types, right? Because when we talk about what you want to store in a container, it has a type, right? Like we said, liquid, solid, and all those stuff like that. So liquid could be water, could be tea, it could be drink, it could be alcohol, whatever, don't know, right? Whatever, but it's under what? A type called what? Liquid. So that's just the same concept here. So we have what we call data types, which we'll look into, right? Hopefully before the end of this class, right? So I'm going to try as much as possible not to be too fast in trying to cover a lot of stuff that I miss out. So I'll try to hit things as, in depth as I can. So the colon here is just used to point that, okay, fine, this variable called age, that is an immutable variable, right, is of type integer, meaning that this variable will only store what integer. So this is what we call variable what declaration. So we haven't stored anything. I have just said that, okay, give me a space in memory, right? Remember, that's what the variable does, right? A variable is just a name storage, and stuff like that. It's in a particular memory, right? In computer. So give me a space in your computer memory. I want to put in, that space should be for age, right? My variable called age that is going to hold integers. So that's just what variable declaration. But we have what we call variable. Sorry about that. Variable initialization. So variable initialization means that you now give that your variable a value, right? You now give it a what value. So I'll say something like val age of type int, and then I'll use this and say, let's say 5. 5 is an integer. Okay, so don't be mistaken, right? This is not an equality sign. It's not equal to, right? This is an assignment what operator. Take note of that. Equality, which we'll actually learn, is a double of this assignment operator is equality, right? But the single one is what an assignment operator. So it what says, so basically what it says is take this 5 and store it in this what immutable variable called what age that holds integers. So that is variable what initialization, right? You are creating the variable and what giving it what a value. Now, of course, you could actually shorten this whole process by just saying val age equals 5. Or, well, there are two ways. You could do this straight off, which is what we have already done, right? Or you could just actually say val age equals what 5, right? So this is you creating and initializing. Here is actually a declaration and initialization. Now, this is the same as this because of what we call type inference. Type inference means that Kotlin is able to deduce that, okay, this 5 actually is an integer. So you don't need to explicitly tell it in this code, right, that it is 5. Kotlin can actually just know that, oh, this is actually a 5. So it knows that this age variable actually holds what integer, right? Okay, let me stop and take questions. Is there any question? I don't want to assume that everybody's just following. If there's no question, I'll just move on. You can raise your hand or use the chat. Any question? If there's none, I think I'll just move on. Okay, none. So I'm going to just we'll talk about data types fully, right? But for now, I just want to do some introductory stuff. Now, I'm just going to introduce another kind of data type, which is what we call the string. We'll look into data types separately, but I want to explain a few things about variables. And with that, I need to also at the same time talk about some data types, because there's no how I'll actually explain variables properly without probably calling a data type. So let's look at this other variable declaration. Let's say name, and then so now I want to create a variable, an immutable variable called name, or so it doesn't confuse you. Let me just say student name. Okay, we'll talk about variable naming rules. Okay, name, right? And then, of course, a name is not, when you create a container that takes names of people, what type of data will be there? Who wants to answer? Just think of anything that say anything that comes to your mind, right? Either on the chat or you raise your hand, right? When we create a Dilo says string, right? Okay, so yes, he's actually right. Now, what is a string? Well, like I said, we'll go into data types, but basically a string is actually a sequence of characters, right? So just like you have, yes, a set of characters also, that's fine, Evelyn. So just like you have Evelyn, right? You have E, V, E, L, Y, and N. Each of these are characters, each of them on their own, right? Each of them on their own are what? Characters. But when you bring them together, right? When you bring them together, they now form
You can't see the screen, sir. You can't see the
called
screen.
what? Evelyn. Yes, yes, yes. Sorry about that. Coming up right now. Okay, I think you should be able to see it. Yes, you should be able to see it now, right?
Yeah, we can see you.
Okay, so where was I? Okay, yeah. So each of these letters, each of them, they are what? Characters on their own, right? But when you bring them together, right, it's now a set of characters and it's now a string, right? So strings are actually written in quotes, right, or called quotation mark, right? Somebody saying he can't hear me. Can somebody, can you guys hear me?
We can hear you. We can hear you. We can hear you. Maybe it's the person's network.
Okay, Prosper, probably you need to check your network. Okay, so in so Kotlin, right, of course, we strings are written in quotes, right, or what you guys know as quotation mark, right? So let me just so this, okay, let me delete this, and then inside I'll say Evelyn, right? So the student's name is Evelyn. So what am I, so what is this? This is an immutable variable called student name that contains the value called what? Evelyn, which is a string. So that means that this variable type is what? A string variable type, because it holds a string. It's a string is actually stored in it, right? So that's actually, I just wanted to introduce that because of where I'm going to, because here I talked about, here I'm also talking about type inference. I think I mentioned type inference, right? So yeah, I mentioned type inference, right? Where the compiler, the system is able to automatically, just deduce the variable what type. So you don't have to, if I wanted to explicitly declare the type of this variable, I'll do something like this and say string. Sorry about that. Yes, and say string, right? So this explicitly telling the computer that, hey, this variable is going to hold what? String values, right? But of course, type inference, with type inference, I don't have to actually what? Do that, right? So these are just a few things we can do with variables. Now, some other thing we can we'll look at as far as variables is concerned, right, is what I call a string template, right? String templates basically, let me just string templates, right? So Kotlin actually allows you to embed variables, right, within strings, right, using what we call a string template. So let me give an example. So I think at this point I'm going to run code, so I may have to comment this out. Okay, so let's say val first name is okay. We're still using, let's use, since she answered, and then var last name NGU, right? I hope that's your last name. Well, that's fine.
Yeah,
So
yeah.
okay, so now I want to create another variable that will store the full name, right? So I want to store the full name and print it out, right? So of course, that's just, so I'll have to comment these guys out because I want to actually run a code. So this is how you comment codes out. So when you do this and you run this code, right, the compiler will skip all this, right, and just focus on these other ones, right? So so I could actually just say first name I'm going to show you two, show you, because I want you to understand. So remember, first name is holding a string, right? So assuming I want to see the result of first name, I'll use what we call the print statement. So in the print statement, right, it just prints out the result, to you, right? But there is two, there's print and there's print ln. So print statement alone will print out, let's say I want to print out the first name, and then I want to print out the last name, right? So when you click on run here, of course, you'll see the result here. So you can see that it gives you Evelyn and then Ungu. I don't know if I pronounced that right, but with print statement, it just prints everything on the same line, right? But when you use the print ln, which is print line, so what this does is that immediately after printing the first command, right, it takes the cursor to the next line, right, and then prints the other one. So running this, the surname now comes what's down, right? That's just the difference. Okay, so so assuming I want to print both of them, right? These are, we'll learn some of all these things. Do we will get to the actual data type, but I just want to really explain these things. So I'm just going to do something like this. This is actually called concatenation, where you can join two strings together. Just don't worry, we'll look into that, right? Concatenation. So that's what this plus sign does for strings. If it's integers, it will add the two numbers, right? But here it adds the strings by just concatenating them, bringing them together. Okay, so let's do a print ln here, and then also let's just print the full name, right? So when I run this, so you can see Evelyn and then her surname, right? Name and surname. So we just concatenated. So you see there's no space in between, right? So I want to actually print this as a statement, right? So that's where the whole string template comes in, right? I can now do something like this. So instead of doing this, right, I can just do this, right? Her full name now, right, will now be say my name. So the interesting thing you need to know about strings, right? Whenever you want to print a string, it just gives you exactly what is there, right? It just gives you exactly what is there, right? So this will just give you exactly what is stored. So here I'll just say my name, or you can say my name is. So with string templates, right? With string templates, you can embed variables within this string literals between inside here. You can embed variables and it will read it as a variable, but of course you have to do something for it to read it as a variable, else it will just read it as a text, right, as a string. So if I just do something like this, let me cut this and print full name, you see that it tells you my name is, that's what's going to print for you, right? My name is. Now, but what if I want to say my name is first name, right, last name? Now, actually, what I want is I want to say my name. I want this, what should be stored here should be my name is, instead of first name, I want it to show Evelyn, because I've created a variable called first name, and the content of that variable is what Evelyn. So I want Evelyn to show here. The content of last name is Ungu. I want Ungu to show there, right? So I want to actually see my name is Evelyn Ungu. So, but if I run it this way, it's not going to give me that, because it's just going to read this variable as an actual, just a text, right? It's just going to read this as a string, right? So how do I fix that? So we just add a dollar sign. Is it, yeah, pound? Dollar, actually, yeah. Right? So with this now, it now reads this first name as a variable, right? And then reads this last name as a variable. So running this now, you should see my name is Evelyn Ungo, right? So that's actually what string what template. So this is what's called a string what template, right? So we are able to embed variables, right, inside of a string. So instead of reading my name is first name, because of this sign, it means we are telling the compiler that, hey, this guy actually is a variable. It's not just first name. So don't just print it out. Go and get the value of that variable, right? Another thing I want to introduce us to, another thing about variables is that variables can be nullable, right? I'm going to talk about, we'll look into what's it called? Null, right? It's a very, very important thing to note, right? Let me just, so nullable variables, right? So variables, these basically nullable variables, right, is just to present variables that can hold either a value or a null, right? For a value or a null. So what is null, right? I know that's the question that a lot of you will be asking. As we're going to actually look into it, right? But let me just touch it a bit. Now, null represents the absence of a value, right? Null represents the absence of a value. So you use null to indicate that a variable or an expression does not currently hold any valid data. Take note of that, right? We use it to show that a variable, or maybe not just a variable, could also be an expression, right? It's used to show that it doesn't currently hold any valid data. So Kotlin actually is designed to help prevent what we call a null pointer exception, right? We'll talk about that, right? And it's actually a very common error in languages that allow variables to hold null values, actually. And that's one major issue with Java that Kotlin actually helps to really tackle null safety, right? So Kotlin actually provides two approaches to dealing with null values. So let's just talk about that briefly, right? First of all is what we call nullable types, right? So in Kotlin, you can explicitly indicate that a variable can hold a null value by using the nullable type syntax. There's a syntax to actually use, and that's basically a question mark. That's just it. So you can have something like this. Let's say val not. Let me just say val. Okay, let me close this out. Sorry, and let me create a bit of space. So we could have something like val name of type string, and then I put a question mark here. So what am I trying to say here? So basically I am saying that, look, this string with a question mark here, right, is a nullable type that it can either hold a string or a null. That's basically what I'm doing here, right? So I'm explicitly indicating that this variable can actually hold a null value, so that when I'm running my code, I won't have a null pointer exception that will probably crash my application or not, because I've already informed the system, the computer, that, hey, this variable can actually have a null it can have a null value, right? So that's actually just that. Of course, there are non-nullable types, right? Variables in Kotlin that actually, by default, actually, variables in Kotlin are non-nullable. Non-nullable means that they cannot hold null values, right? They cannot hold null values, and this is by default, right? So that's why. And so if for some reason your code is actually going to, not have a value, that's where you now probably have the null pointer exception and stuff like that. So this actually helps to, prevent your app from crashing, because you're telling that, hey, this variable can actually hold a null. So that's why you need to explicitly state it, because by default, variables in Kotlin are non-nullable. They cannot hold null values, right? So that's just to note, talking about nullable variables, right? Okay, so okay, so I think that's just a bit, right? The last one I just want to look at, some of these things, we'll look at them, a lot of them, right? A lot of things that can be done, but this last keyword, right? Last, I want you to know, not really a keyword per se, but there's what we call late initialization, right? And you use this a lot in your when you're building applications, right? So now we use late initialization if you need to declare a mutable variable without initializing it immediately. Remember what we talked about, initialization means you're giving it a value. So we actually can declare a mutable value, right? Um, and remember, I'm using the word mutable means you can update it, right? So we can declare a mutable variable without initializing it immediately. So, but to do that, you have to use the keyword called late what init, right? Is use the late unit what modifier, right? So what does this do? This basically just promises, is you just promising the compiler, hey, don't crash my code, right? I know I created this variable and I didn't store something, but hey, I promise before I use it, I will store something inside. That's basically what late initialization actually what does. You're promising that, hey, before I use this guy, I will what give it a value, right? So, and of course, before you use it, you should actually give it a value, else you have an error in your what code, right? So that's actually late initialization. So this is basically how you can just declare that. You can just say late init var, and then you call a name of type probably was string. So you're creating a variable called name that should hold a string, but you are not initializing it now. So you use the late init what keyword, but before you use it, you should initialize it, meaning you should give it a value, else you run into what problems. Okay, so one last thing I'm just going to talk about is lazy initialization, right? Uh, Lazy initialization. So now it's almost the same thing as late init, right? But we use this for properties that are what word will I use? They are expensive to initialize computationally, right? They're expensive to initialize. So we use this lazy, call it a lazy delegate, to ensure that they are initialized only when they are needed, right? You still see a lot of this. We'll get to use it, right? This is basically how it looks. You can just say val name. We use it mostly. You use it mostly for view models, but of course you use it for other things. Um, of type string, and then we'll now say by lazy. That's how it is declared, right? And then you can now put in whatever you want to put in here in your code, right? So that's basically lazy what initialization. So but we use it for properties that are computationally expensive to initialize. They take a lot of resources, CPU time, and all of that to actually initialize them, right? So we use this to ensure that we only initialize them when we need them, right? So we don't have to initialize it when we are opening the application for the very first time, except it is needed, right? But if it is not needed, it stays the way it is, right? This actually helps you to kind of manage what resources in your application or in your what code, right? Okay, so let me stop again and take questions. If there are any question, you can just raise your hand. Okay, Evelyn has a question. Go ahead.
Okay, so back when we were talking about the first name and last name, you used the dollar sign to is it concatenation or something? I wanted to ask whether you could use any other symbol. Like, is it just a must? It must be the dollar sign or another symbol. And also, I didn't really quite understand everything you put across about nullable variables. So could you explain that part again or break it down a little bit? Thank you.
Okay. Okay, so let me start with the first one, right? So concatenation, you use the plus sign, not the dollar sign, right? The dollar sign is to when you want to tell the compiler that, look, in this string, right, this particular first name, right, is not just a string, because when you want to print out a string, you're basically just printing out whatever you put there. So that's why you have my name is. So if I actually take out this dollar sign and print this out like we saw, right, we'll just have my name is first name, last name. But I want the compiler to be able to treat this first name as a variable that it is. So that's where the $sign comes in, right? So it's not the concatenation. So concatenation is when we have first name plus last name. So that's what concatenation, that's what you use for concatenation. Okay. Now, okay, so for the variables, right, nullable variables, we'll get into null. Actually, we'll still talk more about it, but let me go back. Let me go back a bit. So first of all, I said null, right, represents the absence of a value. So when you say something is null, it means that there is no value. When you say a variable is null, it means that there is no value, right, in that variable. There's no value in that container. So you could say your growth rate. Okay, right. Maybe you have a container for to store your Gary, right? What we call groceries right now in Nigeria. Okay, interestingly. So if it's empty, right? That's an absence, right? So it's null. I'm just trying to use a very weird analogy, right? Something you can relate with. So null is the absence of a value, right? Now, by default, when you create a variable, by default, variables in Kotlin are non-nullable, meaning that they must have a value. They cannot have nothing in it because null is nothing. They can't have nothing in it. They have to have a value, right? But you can make a variable what nullable. Making it nullable means that you want that variable to either have something or nothing. Now, I know that's weird, but the essence of that is this. Okay, just look at it from this aspect, right? Let me see if I can use an analogy. When you go to, let's say, your container, right? A container that you store oranges or whatever, right? And then I want to have orange, right? I want to have, I crave it. And then you tell me to go to the kitchen, right? And that I should get in that container, I'm going to see stuff there. I'm going to see orange there. Now I can go there and the container is empty, right? Now the question is this: how will I feel, right? How will I feel after that? So when you're running your program, right, by default, the compiler is expecting a value, right? It's expecting a value. Variables must have a what value. They cannot be empty. So when it sees a variable that is, that is going to, or for some reason doesn't hold a value, it throws an error, right? And that can crash your application or whatever. So it throws an error, and that means your code will not execute to the end. So to prevent that from happening, we tell the compiler, hey, this variable, we are allowing it, we are giving it the privilege to be empty, to not hold a value, meaning that it can be what? Empty. It can be what? So that means it's a nullable what? Variable, meaning that it can have null, right? It can either have a value or it can either not have a value. And of course, you really, really understand it very well when we start building stuff and getting our hands dirty, right? But that's basically just the concept, right? Nullable variables are variables that can actually have what, either have a value, they can hold a value or not, right? I don't know if that's kind of helps you out. Oh, I think she stepped out. Okay. Evelyn, are you there?
Yeah, I'm here now. Sorry about that. But you don't need to repeat yourself. I'll look through the class again to get what you said.
Yeah, okay, that's fine. Does any other person have a question? Does anybody else have a question before?
Yeah,
Yes, go ahead. Prosper.
yeah, I have a question. So,
Yes.
maybe we are trying to run a code or something. Can you hear me?
Yes, go ahead. I can hear you.
Yeah. Maybe we are trying to run a code or something, and we mistakenly or maybe forgot to assign a value to a variable, a string rather to a variable. Like maybe we created a variable and we kind of forgot to assign a string to that variable. So adding this nullable, is it nullable what? Nullable variable, adding it at the bottom of our code, does it handle the one above?
Okay,
Does it
so
like
one thing, okay, hold on. One thing I want you to also understand, generally, it's for everyone in coding, in programming, right? Remember that your program is a set of instructions that goes from top to bottom, left to right. Okay, so think of it this way. If in your set of instructions, right, to make noodles, I tell you first step, buy the noodles. Second step, put the pot on fire. Third step, put water in the pot, right? Good. And then towards the end, I now put what's it called? Let me see. What will I use? Break egg or something. Maybe you want to make it with, we want to make we want to use eggs, right? And then after making the noodles, I say, okay, I now put break your eggs and stuff like that, right? Understand that your set of instructions runs from top to bottom, left to right. Now, before it gets to the breaking of eggs, you should have done every other thing before you get to that point. Probably that is step 8. So if your compiler is running, it runs from top to bottom. So at the point where it comes to that variable and that variable is empty, right? It doesn't hold a value. It will throw an error there. If you want to cater for that, your declaring of, if you want to declare that variable nullable, you have to do it before it gets to that variable. I don't know if you understand my point. You have to declare it before. We'll talk about, there's what we call global variables and local variables. We'll talk about that when we get into functions, right? So, but it's a top-down approach, right? There's a step 1 to a step 2. So if when it gets to step 2, it needs to do something, but the condition you put or whatever, right, it's kind of way down, right? There's a possibility, except that's a function that it will go into, except that's a process that it needs to get into, right? But if it is not, it will actually throw an error. So you have to now send that information above, right? That, hey, this variable is what nullable, same thing as late init, right? So, but if you're declaring it this way, right, just like we have it here, like this, it won't give you any issue. But when you want to now take this nullable declaration down after you have, let's say you've already done something like this, val name of type string, right? This will definitely throw an error. When it gets to this point, the fact that you've done this here does not save this guy, because it has gotten to this point and it will attack this one is seen first. I don't know if you get my point, Prosper.
Yeah, I
Okay.
get. No,
Okay.
actually, I'm clear now.
Okay, that's fine. That's fine. Any other question? Any other question? Any other question? Okay, no other question. Okay, so I'm going to let's talk about data types in Kotlin. Now I'm going to do this in a very in a way such that I try to talk about it in 20 minutes, right? All of the ones that I will have to talk about in 20 minutes. We'll dive into, it's more like trying to list them out, but we'll play with them in the coming class. We'll now play with them individually, right? Some of them I would kind of just explain them, right? Others will really play with them in depth, right? So the data types in Kotlin, right? There are a lot of data types in Kotlin, and basically data types helps you to represent the different kinds of values, from number values to characters to what we call Boolean, right? So, see, here are the main data types we have. We have numbers, right? Okay, let me leverage on this. So numbers, I don't think I'm going to be running. Okay, I'll run some codes for numbers. Now, for numbers, we have several kinds under that. We have what we call the bytes, right? We have so bytes. So of course, for some of us, who have computer science background. Okay, let me just look for trouble. What's a byte? What's a byte? Let me ask. Anybody wants to help? Anybody? Anybody? What's a byte? Okay, Basif, go ahead.
So a byte is 8 bits, is a unit of measurement for data, kind of. So just
Okay,
8 bits.
so it's an 8-bit signed integer actually, right? So 8 bits there, the bits there, that is when you say 8 bits. Oh, okay, let me just 8 bits, right? So the bits here actually stands for binary digits. So 8 binary digits, right? Actually, it goes from minus 120, I think minus 128 to 127. Yeah, these are just computer science stuff, right? You can just go check that out, right? So we have bytes as under numbers. We have shorts. We have shorts. Shorts is 16 bits, right? And we have ints, which you have actually seen. We have long, just gonna list them, right? We have floats, and then we have double, right? Double is 64 bits, right? But it's a 64-bit floating point number, right? Decimal and all the stuff. So a lot of these things, I'll just drop a link somewhere for you guys to just read up. This computer science stuff, right? Float is actually 32, same 32-bit floating point number, right? Long is 64 of 64 bits signed integer, right? Of 64 bits. Actually just say signed integer, right? Signed integer. Yeah. Int is actually 32. So 32 bits, meaning 32 binary words digits, right? So those are numbers, right? With respect to data types, right? So you could actually declare a variable as a byte, to store short, int, long, double, float, right? The ones you actually use a lot, right? Int, floats, double. Yeah, you could use a long, but of course, some of these things, right? You may not use it, of course, just in this starting phase, right? But it's just good to actually know it, right? So number is a data type, right, which you have byte, shorts, int. I've used int, right? We will use some of these other ones, especially float and double, right? Another data type that we have, right, is the characters. Sorry, characters. Right, characters. Of course, the keyword there is char. It's called char. Some people call it car. Well, it's up to the pronunciation thing, but char is what I call it. So this is actually I think 16-bit Unicode character actually. Yeah, 16-bit Unicode character. So like I said, some of these things I won't really start explaining them. It's something you can just go check out, right? But actually car is actually, so it's just like you'd say var name type string, you'd say var name var number type char, char, right? We also have boolean, right? We also have boolean. Now boolean actually which is actually called bool, right? Boolean actually represents true or false values, right? It represents true or false what values. Okay, so when you say something like 5 greater than 4, right? So it's either true or it's false, right? So that's a data type. Boolean is a data type. We also have strings, which you have actually seen, right? So a string being what, a sequence of what, characters, right? Sequence of what, characters. And then we have arrays, right? Like I said, I'm just going to list them. So we'll look into them one after the other, but that will be in the next class, right? So we can actually play around with these data types and see what can we do with them, right? So the reason I'm going this way is because you said we should take the language first, right? Which is also that's actually a wise choice. But any of them actually works with me. So then we have array. So array is just a collection of elements, right? Let me use the word elements, so it's a bit generic. A collection of elements of the same type, right? Of the same type. So it could be a collection of integer elements. It could be a collection of string elements, right? So it's a collection of elements of the same type. Another data type we have is what we call collections, right? Collections. Now, these collections there, you have lists, we have sets, and we have map. These are collections, right? They can actually hold multiple what values, right? They are collections, list, set, and map. We'll actually look into these ones definitely, right? Yeah, so of course we also have nullable types, actually. We actually have nullable types, right? Because all these types actually can be used as nullable types if you just append this question mark to it. So if you could just say int this, that means this is a nullable word type, right? If you say string with this, means it's a nullable word type, means it can actually hold either a value or not, right? Okay, so that's that. Well, there are other data types, right? Like we're going to look at enums, right? It's actually a class, right? But this basically just represents some a set of values, right? Often used for defining constants or options, right? So we'll just look at them, right? Some of them just brush through it so you actually know about that. We'll actually look at range, right? We'll look at the range data type, right? It uses the operator and double period, right? Uses the double period, right? We'll actually use that when we want to play around with numbers, right? When we want to play around with numbers, we get to use that. Okay, but let's look at how would these things look like if you want to actually declare or initialize them. How do they look like, right? So create let's just do that in the order that we did it here, right? So from int, so for the int, right, you could just say val age of type int, right? And then you can say I don't know who is 90 years here, right? So that's for integer data type. For double, which we'll mostly use, we have pi for some of us who are mathematicians, right? Remember pi, which is 3.141, right? Or 5, 9, and all of that, right? For string, of course, we have done that of string. So this is how you declare and initialize it, right? Then just so who were we using? I think I've used Evelyn. So let's use, who will I use here? Okay, the other person that answered, Abasi. Okay. Yep. Yeah. Okay, and then for Boolean, right? For Boolean, right? We could just, how do we declare and declare a variable, a Boolean variable? I could just say val is student. This is the name. Remember, it's just a name. It could be anything, right? Or I could say val eating. That is, have you eaten, right? Okay, of type Boolean. And then I would say this is probably true, that you have eaten, or false, you have not. So we're declaring a Boolean variable and we are storing the value what's true. We are declaring a string variable and we are storing a string. We are declaring a double variable, a variable of a type double, variable of type age. Which other one did we have? Okay, we have array. So how do you declare that? I could just say val grades, right? Which is of type array. Now, so an array, remember, we said that it is what? A collection of elements, right, of the same type. So we need to state the type, and we do that here in the Angular, what we call an Angular bracket, which is just your less than and your greater than, right? And I'm just going to pass in data type there. So what type of elements, right, do we want to store in this what array? And then how do you initialize it? How do you store it? We'll just do this. Don't worry. I know we'll get into them one by one, right? So let's say 3, 6, 9, because they're integers. So the first element, remember I said a collection of elements of the same type, right? So 1, 2, so we have about 4 elements here, but they are all integers. Okay, and then so we talked about collections, list, right? Map, set. So let's say we want to create a list, right? So I could say of our letters is just a name. So I'll just say list, and then I'm basically declaring the type, right? Or I could say list of, let me use another data type, which is the char, right? And then to initialize it, I'll say list of what? So in strings, right? For strings, we use the double quotes, right? But for characters, we use a single quote. So so if it's Abasifriki, I'll say A, give it another one, A, B, A, and then just like that, right? So this is what a list of what's characters, right? Okay, let's do, I think I skipped floats, right? Floats, which is this 32-bit floating point number, which is a number data type. So we could use temperature, right? Let's say I create a variable called temperature, and I want it to hold a what float, right? A float variable. So I could just say, let's say 14.5, and then I'll just add this F, right? Don't worry, we'll get into this, right? But these things are usually just computer science stuff, but we'll look at that. I'm just showing you how to declare and initialize these various data types, right? We'll still look into them, right? And of course, for the nullable data type, right, I'll just say nullable. This is a variable, so I can call it anything, right? Remember, variable, you can call it anything. Nullable value of type int, and then I'll put the question mark, so it means that it's an integer, an int what, a nullable what, integer, right? And then I'll just pass in null. Null here is what, the value, right? Means that it's empty, right? There's nothing there. So that's actually that, right? Just to, we'll look at all these other ones as we move. So the last thing I would look at, and then we'll call it a night. We'll take questions, and then we'll call it a night, right? Is naming rules for variables, right? So we don't just name variables anyhow, right? They are kind of like guidelines, right? There are certain rules that it must actually follow, right? And we're going to look at them. We're going to look at them, just a few, right? But as we keep on moving with the course or this training, right, we'll get to familiarize with them. So, but first of all, right, variable names has to adhere to, certain rules and conventions. The reason is to ensure code readability and maintainability, right? So the first rule that we're going to look at here is what we'll call I just let's say, okay, I'm not going to be running any code, so we can leave out the comments. Identifier, let's say identifier naming, right? So now your variable names must start with a letter, right? Variable names must start with a letter, either uppercase or lowercase. All right, so it must start with a letter, or an underscore, right? Or an score. So underscore is this symbol, which is this guy, right? That's an underscore, right? So your variable names must start with what? A letter or an underscore. Now, subsequent characters in that variable name can include letters, digits, and underscores, right? So just like I can decide that in this variable called letters here, I want to have 2 inside. That's fine. But I should not have 2. Like I shouldn't say 2 letters. No. You can see the color has changed, right? So your variable names must start with a letter or an underscore, but subsequent letters can actually have underscore and digits also. Now, another thing to note is that variable names are case sensitive, right? They are case what sensitive. So name and name are 2 different things, right? This and this are 2 different things, right? Because it is case sensitive. So if you created a variable and called it name with small letter NAME, and then created another variable called name with capital letter N, they are 2 different variables. So it is case sensitive. That's something you need to understand. Now, the second thing, right? This is just for identifier, right? Identifier naming. Now, but there's also what to call the naming convention. Now, naming convention is that you need to use descriptive names that convey the purpose or meaning of the variable, right? You need to use descriptive names that convey the purpose or meaning of the variable. So that's why you see, okay, fine, I created this variable and I called it name because what I'm storing is actually the name of someone. You understand, right? I named this one age. What I'm storing actually is 90, like actually is an age, right? So your names, like I see this one, letters, right? Actually, what I'm storing are what? Letters. Temperature, I'm storing temperature, right? So your name, right? The name of your variable should convey the purpose and what meaning of the variable. Now, another naming convention you should pay attention to is to prefer there's what we call camel case for variable names. Camel case means that you start with a small letter, right? The first letter starts with a lowercase, and then you capitalize the first letter of each subsequent word. What does that mean? I just use it. So assuming I want to create a variable called first name. Those are 2 words. First is a word, name is a word. So first starts with a small letter. Name is another word. So the first word in that, the first letter in the next word starts with a capital letter N, right? So you could have a first name, you could have last name, or you could have what variable name can I use now? Username. So user, small letter U for the user, then the name, capital letter N for that, right? Or item count. You want to count an item. So you can see that when I use username it as a variable name, it passes the message of what I want to store, what that variable is going to hold names of users. Item count, it will hold, more like a countdown or something, to iterate an item. Last name is holding the last name of someone. First name, you understand? So that's actually what. So prefer camel case. Use this, right? For your naming when you want to name a variable, right? Now there are other ways actually, right? You can use this instead of this username. You can do this, right? Sorry. You can also do this, but avoid it. Avoid it. It's something I've come to understand, right? Just avoid it. This is better. So prefer to use this is I think they call it snake case, if I can remember vividly, right? So, but use camel case for your variable excuse me, variable names. It's very, very, very important. So these two things are things you should actually pay attention to. There are other things like for example, if you want to name constants, right? There's what called constants. You get to use it, right? You use upper letters, right? For example, if you are doing maybe you're building an application where a mathematics stuff, right? Where you're going to be using pi, right? You're going to be using pi in a lot of places. You can create it as a constant. That's an example because the value will not change any day, anytime. Constants should represent values that are known at compile time. and they do not change during the program's execution. They don't change. So I could just, instead of that, of course, this is how you declare constants, right? Say const, use the keyword const to declare that that variable is a constant. And then I'll say pi, capital letter P, I, and then now give it a 3.14 and that, and likes, right? So that's just a naming convention. So constants, you name them with all caps, right? They're all capital letters, right? So another rule, right? Naming convention for Boolean variables. Now, this is very important, right? For Boolean variables, right? Use names that indicate a question, right? Use names that indicate a question, or how will I put it? Or a predicate for Boolean values. So what do I mean by that? So prefix names, like your variable should start with prefix names. Like you should prefix your variable with names like is, has, can, right? So instead of this eating that I wrote here, I could actually say has eaten, right? Because it's a Boolean variable. So you should prefix it with what names like is, has, can, or similar words that just makes the purpose what clear. So that's actually something you should know. So you should use names that indicate a what question, right? You could use something like is ready, right? Is ready could be a variable name, which of course you can see. It's either when you say is ready, hey, is ready, is it ready? True or false? No or yes, right? You can have something like has permission, right? You understand, stuff like that. So that's something to also what note. Okay, so I think we can actually, I think that's just that for now, right? That's just that for now. Okay, so I think this is where we'll call it timeout. Any question before we call it timeout? So in the next class, we will get into these data types and then play around with them. Yeah, we'll play around with them and see what we can use them to do. How are they implemented, right? How can we, get to use them to achieve certain goals, right? Okay, so yeah, questions. Okay, yeah, Evelyn, go ahead.
Okay, so I kind of forgot the part, but like you were doing something and about bytes, I think 16 bits and 32 bits. Like, is there a reason, like, how do I put this? What makes 32 better than 16, or what makes 16 better than 32? Is it like, is there a context for using them or to store more things? Or like I don't know why the numbers are different. Like the numbers part just confused me entirely.
Okay. So like I said, that's actually a computer science stuff, but this is it, right? So when we talked about bits, right? Bits actually represents binary digits, and binary digits is zeros and ones, right? So when we say 8 bits, we mean 8 binary digits. So it could be 1 1 1 1, like 1 in 8 places, right? 16 bits means, which is short, it means that it takes 16 binary digits. Now all these things, right, each of your bits actually take a space in memory. So when you create a variable that stores a byte, it means that the computer will allocate what space for 8 bits only, for 8 binary digits only, and nothing more. I think we'll practicalize that
Oh
in the
yeah,
next
yeah,
class.
yeah.
So
Makes
when
sense.
you use short 16, so the computer will allocate memory for 16 binary digits and nothing more. If you need more, you have to now upgrade it to int. If you need more, if your binary digit is going to be more, which you almost not use, of course, all through this course, you almost not use long 64, because what are you storing that has up to 64 that will take up to 64 binary digits, right? So that's basic. I don't know if that actually clarifies it for you.
Yeah, I did everything I need. Thank you.
Okay. Chinazom, go ahead.
Okay, mine is not just like a request. How can we get a link, to actually go back to the video?
Okay, so the link is going to be on YouTube. I'm going to upload it on YouTube, right? So I actually we usually stream live on YouTube, usually. But I'm not going to start it out now, probably start that from next month, right? But for now, after classes, I'm going to upload it on YouTube, so you to always be on. So just make sure you're subscribed to our YouTube channel, right? So once I upload it, it notify you that this video is now online. You can actually go back to, go through it. Okay.
Okay.
Yes. Adelinda, go ahead.
Okay. Truthfully, this whole thing is confusing. I can't even got to this when we got to this data type. I don't know if there's anything you can read up for us to understand all of this, the meaning of all these things like byte, float, double, character. Is there anything that we can read up so that when we say these things, like, we don't understand? That's for me.
Okay, that's fine, right? I'll drop a resource for that, right? Though we're going to go into data types in our next class, right? We're going to go into data class in our next class, and then we'll pick them one by one, right? And then play around with them, right? But I'll also drop a resource where you can actually just read up and prepare ahead. Is that fine? Hello, Adalinda, does that help?
Yes, thank you.
Okay. Okay, any other question? Any other question? Any other question?
Uh, please throw more light on the lazy initialization.
I should throw more lights on lazy initialization. Do I have lights? Okay, let me give you, let me turn on my torch. Okay, so well, we're talking about lazy initialization, right? I said we actually use it, right, when we have properties that are expensive to initialize. Now, okay, so let me see if I can get, let me see if I can think of something relatable, right? Okay. I'm trying to look for um something. Okay, let's think of it this way, right? Let's say you have a function, right? Let's say you're a house help. Okay, pardon me. Let's say you're a house help, and your function is to make sure that the whole house is clean, right? That's your function, to make sure that the whole house is what clean. Now, if I tell you to clean the whole house, sometimes, many times there are persons who Saturdays is clean up day for them, right? So to do a total cleanup, it's usually Saturdays. Mondays to Fridays, we go about that. We go about our business, and then Saturdays, we now say, okay, fine, do total cleanup. Now, that's to actually do that work. It's actually a lot of work, right? It's a lot of work, which that's why we only call it on Saturday. Total cleanup is called on Saturday or on Sunday. We don't call it during the weekday because it is an expensive action. It takes a lot of resources, right? So we only call it when it is needed. So when probably you've seen that, oh, this house is getting messed up. So hey, that is when you now call that function of what cleaning up the whole environment, right? So you don't, maybe you have to cut the grass, you have to trim them, you have to trim your flowers. If you have to wash the toilet and all those stuff. You don't do it during the weekday. You don't do a total cleanup. No, there are days like there are estates where right, in fact, not even estates, actually states where I think first Saturday or last Saturday is cleanup day, right? They don't do it every month, they do it just one Saturday, right? Because that task is an expensive task. It consumes resources. So you don't just do it anyhow. You don't call it anyhow. You call it when you need it. So that's lazy initialization. When you have a function, right, or a value that for you to make use of it, for you to initialize it, it actually takes a lot of resources. So what you do is that you call it lazily. That's the lazy initialization. So we just create it and keep. We don't call it until we need it, right? So it's a bit different from late initialization. right? They're almost the same thing, right? But of course, for late initialization, you're basically declaring a mutable variable, right, without giving it a value immediately, right? But in late initialization, right, it already, you have everything is said, but you don't initialize until you need it, right? Until you need it, right? Late initialization more like a promise that, hey, before I use this guy, I will give it a value, right? Lazy initialization is this: I will only use this guy when I need it, right? Don't even call it at all. So you, of course, you won't even bring up that function until you actually need what's that function. I don't know if that's, I was trying to use a, different way to go out. I don't know if that helps, right? Does it help? And that's, was that Nietzsche that asked?
Yes, it helps.
Okay, okay. Any other question? Any other question before we call it a night? Okay, so in the absence of none, I don't know. Let me just God first. Can you just maybe say a few words and then we'll round up? Let me call on our mentor. Yeah. Hello, God first. Are you there? Okay, so I think our mentor is not available. Okay, so I think that's basically that from me. So in our next class, we'll get into data types, right? And then get our hands dirty with data types. What are they all about? How can we make use of them? But the video is going to be available, and I'll drop a resource on data types ahead, so you can probably just read through and prepare. So you just make the class actually easy for me. Okay. So